just a quick summary of last time. We'll go in and see some examples in the code to show a few things from last lecture, but just a quick reminder, a quick summary. The content length that we send, that header, has to be the length of the body of the response in bytes. So if we're using an encoding like UTF-8 and we're using non-ASCII UTF-8 characters, we have to make sure that we're taking the length in bytes of the response. If we're just taking the length of the string and we have non-ASCII UTF-8 characters that take more than 1 byte to represent, we're going to get in trouble with that. And I'll show examples. I quickly showed examples yesterday. We had some technical issues and other things. But we'll show it again and make sure it gets across a lot better this time. Also, the Twitch, we lost streaming last time. I did record the video locally. I asked my TA, I'm not sure if he did it yet, but I asked him to stitch together the Twitch video and the local recording to upload that to YouTube. So if he did do that by now, you should have that recording on there. So with that, let's talk about a few more topics that we didn't get to in the slides. We talked about text and text encoding. If you have ASCII, if you have UTF-8, or any other text encoding, you have to encode the string before you send it over the internet. The internet only understands bits. We usually talk about them in chunks of 8 bits, so we call them bytes, or octets in the documentation. The internet only understands these bits. It's only high and low voltage, light or dark on fiber. So what about non-text data when we don't have these encodings? Well, this actually gets a little bit easier, but it is something you have to be aware of in your code, whatever language you chose, how to do this specifically in that language. So say I want to send an image over the internet. There's no text encoding for that, for an image. So what we do is read the file as in its bytes. Just read the bytes directly of the file and send those bytes. So each language is going to have some way to open up a file as binary, just reading all those hex values or however you want to think of the representation, reading the bytes usually. Read that file as a byte array and then just send those bytes. So this actually is a little simpler than text. Text gets a little more complex because we have different ways of representing it. But if you're sending binary, just send the binary. And make sure you get the length in bytes of that file. The file, if you open up your browser, go to your console, and look at the size of the response, that should exactly match your file size. If those two match, you got that right content length. The content type we didn't talk too much about. For homework 2, we just stuck with plain text with the content type of text/plain. But what did that mean, and how do we represent other types of text? So, and other types of values. So we need some way to tell the browser how to interpret the information that we're sending it, and that we do that through the content type. There's at least one part to this, the mime type, we'll talk about in the next few slides. But you can also add optional characters after it if you need to specify, for example, in this example, the character encoding. If I want to say explicitly this is UTF-8, I can send that UTF-8. If you recall last lecture, I had the UTF-8 character that wasn't displaying right in my browser. If I set the char set to UTF-8 in here, it would have displayed properly because it wasn't using the right encoding. It wasn't using UTF-8. Usually, in many cases, UTF-8 is assumed. I thought I could get away with that one. What I was thinking, and why I haven't ran into that before, is if you're sending UTF-8 characters in HTML, and we have that tag in the header that says I'm using UTF-8, the browser will see that HTML tag and then know to render in UTF-8. If you don't have that tag, so I was just sending raw text, I need something to tell it to use UTF-8, and that can be done in the char set as the content type. So that would have been one solution, or just sending HTML with that tag that says UTF-8. Browser wasn't, the specific browser I was using there wasn't assuming UTF-8. I believe it was trying to decode with ASCII. So somewhere in there, we have to say UTF-8 if we want to use that, just to be safe across all browsers. So the first part of that content type, and the only part we're using in homework 2, is the mime type. This, I want to say has to, I'm always hesitant to say any absolutes in the internet because the way all browsers are implemented, everything's going to work a little bit different. This certainly should always be in every response. The mime type is going to tell the browser how to interpret the data in the response that it's receiving. So if your browser is requesting a certain path on your web server, the browser is not going to assume, like you would think it might assume it's going to be HTML. The browser will not assume that it's getting HTML as a response. A lot of web servers are not made to serve HTML text. If you have an API that doesn't have a front end, for example, a lot of the information sent back is going to be JSON information, or in some cases CSV, just plain text as CSV. It's not always going to be HTML. So we do have to explicitly tell the browser, hey, this is HTML, please render this as a web page. Because it's not always what you're serving. You have to tell the browser explicitly, this is a web page, treat it as such. We do that through mime types, which have two parts, the type and subtype. A little history. This came from email, but it's been adapted all over the internet, most notably in HTTP. Type and subtype. Some of the types, we've already seen text. This means that we're using some text encoding, usually UTF-8. Image, if we're sending an image. Video, if we're sending a video. A lot of the types are pretty straightforward, pretty self-explanatory. There are tons of these. I linked to some documentation on the website. I linked to one site that gives a comprehensive list of every single mime type and subtype. There are lots of them. They're a ridiculously long list. Feel free to just scroll through it real fast and go, wow, there's a lot. Most of them we won't use, but some of them are specific to certain industries, certain companies and stuff, and they submit their mime type to the documentation just so everybody's aware of it. Most of them won't be used by many people. But these are the major types. Text is mostly what we're focusing on right now, but we'll also use image. For homework 3, you have to use this image type also. Then there's subtypes. I don't have too much to say about these, but here's a good list of them that we'll end up seeing. The top one, obviously, plain text. We've used that in homework 2. You're using that right now. Assuming you got started, please start. If you haven't, that's coming up. And there's a decent amount to do in that one. HTML, if you want it to be rendered as HTML, use HTML. CSS, JavaScript, self-explanatory. Tell the browser what this content is supposed to be, and the browser is going to interpret it as such. Image, specify the image type so it knows how to decode that binary. For example, PNG and JPEGs, they're going to use different encodings, they're different file formats. The bytes represent different things in different positions for each of those formats. Tell the browser what it is. Though a lot of browsers do end up, I was experimenting with this, a lot of browsers, if you use the wrong image mime type, I even did plain text for an image, and the browser was able to figure it out. I assume it's reading the binary and reading the file type from the binary, but I don't know. Browsers are pretty advanced. Unfortunately for this class, it makes up for a lot of our mistakes, so it's hard to say, you have to use the right mime type, and then the browser's like, nah, I got you. So there are some cases where that'll happen. Some cases where it won't that we'll talk about as well. Video, specify, again, the file type. A browser will try to figure out the mime type for you if you have the wrong one, and this is what we call sniffing. So the browsers are going to get the mime type, and if it just doesn't make sense, or for whatever reason it just doesn't work with that mime type that you used, the browser is going to try to sniff out the correct mime type. So if you send something, it's going to make its best guess. It's got its algorithms. It's going to do what it can to figure that out. And of course, each browser is going to do this differently. If you have the right mime type, you can sometimes get into these situations where the browser thinks it's the wrong mime type. Maybe you got some errors in your HTML or something that just says, I don't know if this is HTML, and tries to interpret it as CSS, or I don't know, whatever. But each browser is going to do this different. So if you have the wrong mime types or the right mime types, but in a confusing way for the browser, some browsers are going to have different behavior based on this, based on their sniffing algorithms. They're going to look for this stuff differently. So we can have big surprises. if this sniffing is happening. So it's become best practice to tell the browser, hey, don't do that, just don't. I know what I'm talking about, I have the right mime types, don't try to change my mime types because I got the right ones, I know what I'm doing. And we can do this through a header called X content type options no sniff. This tells the browser, turn off sniffing, I got the right mime type. If you don't think this mime type is right, don't even bother, just don't render the file at all. Don't guess for me. So this is us saying we're confident in our mime types, so don't sniff it out. So why would we want to do that? So let me give you a scenario. You have a website, users can upload images, and those images are displayed for all users. Basically any social media website, including your projects. Some content, some image, they upload images displayed to all users, meaning every user is downloading that image and displaying it in their browser. A malicious user says, I'm not uploading an image. I'm going to upload some JavaScript that's going to steal everybody's personal data. It's going to hijack their cookies. It's going to do all kinds of malicious stuff to get information to me, the attacker, who wants to steal people's information and do nefarious things. So they upload JavaScript instead of an image. You send that image to all users with the MIME type image PNG. The browser says, this ain't an image, this is JavaScript. I'm gonna run it as JavaScript because it's obviously JavaScript. With that sniffing algorithm figures that out. Now you got that JavaScript running on every user's page. Now you have an attack, you just been hacked. Not even you as the developer, but all of your users just got hacked, which is way worse. All of your users' personal information can be compromised. Or maybe they're not that malicious, depending on how you view this, but maybe their JavaScript just says window.redirect? Anyway, redirect to my site, to some other site. And now your site is completely broken. Any page that displays that image won't render, it'll just send back 301, redirect, not necessarily 301, because it's in JavaScript front. Anyway, redirect the browser to some other page, and people just aren't getting your page. If they're very nefarious in that one, they're going to make that page they redirected to look like your page. And now they can really do some damage. Maybe it looks like your login screen. You type in your credentials. Bad stuff. Yes.
So the no sniff is only handy for times when you're sending to the server, not grabbing from the server?
Yes. So this is when your server is sending a response, and you're setting that MIME type. You're going to say, hey, browser, you're telling the browser that you're sending this to, don't try to figure out the MIME type. Trust me, my MIME type is correct. So it's in your responses. You will read this, once we have uploads, you'll read the MIME types as well. I'm not sure how much it makes sense to have no sniff on a request, on a post. But there might be some attack, there might be some scenario. So I'll table that for now. When we get to post requests, I'll try to remember to bring that up. I don't think it makes sense to send no sniff because our servers won't have, I guess it could have sniffing. I'll table that one.
It's kind of strange that the priority for like fault tolerance is so high, there's actually a flag that says, yeah, I actually follow the standard.
Yeah, it is. It's ridiculous. But it is. But that just goes to show how much those browsers are working so hard to please us. Like, no developer, you can make mistakes. I'll fix them over here. It's kind of absurd how much the browsers do that. But they want those pages to render. They'll do anything they can. Those browser developers. Yeah, it's absurd that this has to exist, but it's there. It's a thing. And I highly recommend setting no sniff. I think I'll make it an official requirement. I was going to add it to homework 2, but I don't know. I don't remember why, but I didn't. Homework 3, I'll probably start saying you have to have the no sniff to have your right MIME types. Oh, I know why I didn't. Because in homework 2, I just said your MIME types have to be right. So I can go in there, myself and the TA can just check your MIME types. If they're not right, we're still going to do that. But we should be setting the no sniff. It's good practice. It's pretty standard these days. Yeah, it does. Just sounds even more ridiculous. It's standard for developers to say they know what they're doing, but it's the world we live in. All right, so let's take a look at a page. I have a lot of my code hidden here. I have separate classes, separate files where a lot of the processing is going on. So if your code, unless you do the same thing, your code shouldn't look like this. You need to parse all that, parse the requests, assemble the responses and everything. But, I mean, I don't want to have the solution to the homework on the projector. So, so let's look at a top level, what's going on with this server. I'm going to serve the main part here, public HTML as a file, and I want to set my content type to some type that's going to be in the response. So what this will do is I'm going to read this file from disk, which of course is part of homework 3. Read your files from disk and serve those files to the user. So if I go into my console, I want to go to the network tab so I can see what's being served. I didn't restart the server. Restart the server. And I get HTML, yay. So what I used for the content type, you saw it in the code, but don't just trust me that that's going to be set as the content type because I have that one hidden. But the content type here I sent as plain text. And I have my no sniff, so I'm saying I'm confident in plain text. Even without no sniff, I believe most browsers are still going to render this as plain text, as they should. So I got plain text, and it just displayed my HTML. It didn't render it as HTML. Of course, not what I want. I would actually like my HTML to be rendered in the browser. So we need to get the correct content type. So if I go back to my web server, say, okay, content type, the right thing, restart my server, and when I refresh this, we should see what we saw when I first went to this tab. We're going to see the actual page. Rendered that HTML, handled it in the appropriate way, and gave me what I wanted. And we can see that content type did change. I'm not pulling one over on you. Content type, text HTML. All right, now let's, which one do let's do this one next. So if we look in here at the requests, I actually have a second request. In my HTML, I do have a style sheet being linked, style.css. I do have that path serving my style.css, which just puts us in dark mode, nothing too fancy. I just want to show the concept. But if I look at this response, my content type, intentionally incorrect, text / not CSS. It should be CSS. We'll change it to CSS. But it's not CSS. Now that style sheet, it was downloaded. The request was made. My server made the response. We can see the request and response in my console. Get style.css. And what I sent back was the 200, okay, content type incorrect, the no sniff, content length of 50, and the body is my actual CSS from that file. And looks like my file starts with a new line, yeah. That 2 blank spaces, one of those is from my file. So part of my file is starts with a blank line, whatever. So it was served, everything worked correctly, but I'm not in dark mode. My page is still not having that CSS applied. In fact, if we go to the console, actually there'll be cancel is the error it gives. If we go to the console, it'll actually tell us, hey, you told me not to sniff anything, but you had this mime type that just doesn't make sense. I couldn't render this as some mime type that doesn't actually even exist. So the browser didn't know what to do with this. It could have sniffed and figured that out, but I told it not to. I said, don't sniff this out. And if we didn't have the no sniff, possibly it would render, possibly not. It depends on the browser, depends on the algorithms it's running, depends on how it's programmed, how it's developed. So let's go back into the code. Change that to CSS, restart our server, and now since we have the correct mime type, that should render as a style sheet. We should get the right, proper rendering on that. So go back to our browser, refresh. With all luck, we'll see dark mode. Now everything's fine. We get no errors here. We can see the response. It's the file that we had. We go to our console, no errors. Everything's fine because we told it, hey, this is CSS. It was, in fact, CSS. So we were able to send that, and everything's great. We're able to render that page just fine. As a quick side note before we go a little further, I have this, you might have noticed this favicon.ico. This request is often made by the browser, and we can actually see this request made if we refresh. If we refresh. If we refresh. If we refresh. Give it to me. Well, if you're working on, if you started homework 2, I'm sure you've seen this. We'll leave it at that, I guess. Usually refresh sends that request again. Not going to bother looking into it now. But it was already downloaded. It's already rendering on the page and everything. I don't have it explicitly linked in my HTML. Maybe if I did that, it would make the request. If you don't mention favicon anywhere, like you do in homework 2, and you still get those requests, the browser will just be like, yeah, let me request the path favicon.ico and try to get that icon. So I am serving at that path. I'm serving an icon, which is just UB logo. What this is, since I got this question in office hours, I saw it a few times, I forgot to mention it. So if you're wondering what this is what the icon that shows up in the tab, how I got that UB showing on this server. I served something at that favicon.ico. The browser requested it, got that icon, and then attached it to this page. Now, this is bugging me, actually. Let's, new incognito might work. I don't know. I'm not gonna bother. I'm telling it not to cache, so that shouldn't be the issue. But anyway, if you're wondering what that is, so you can serve an icon. I'm calling my file to send binary responses, or setting my server to send a binary file. So I'm pointing to that file, opening it just as raw bytes, and then sending those bytes in the response. So if we had access to that response, we'd be able to see the number of that file, be able to see that. So I kind of wanted to show because it matches the file name exactly, but c'est la vie. All right, so let's change this site a little bit. I want to grab this header right here. Now, I briefly showed this last time, but I want to make sure I make this point. If I add some non-ASCII UTF-8 here, and now I have my char set up here, so I don't have to have it set in the response header. Ideally, I would just set it both and not have to worry about anything. But since I have UTF-8 here, we are actually going to get those symbols rendered in my browser this time, unlike last lecture. But I'm going to have all these UTF-8 characters. These are 4-byte characters, so this is going to take up quite a bit of information. I'm going to use my send text response back, which means I'm taking strictly the length of the string. I'm going to take the number of characters in this index file and send the content length as that number of characters. And of course, we should expect this to, actually I didn't have to restart the server there. And we should expect this to break. So we get all those characters, but we only got up to welcome. If we look at the network, if we look at the response that we sent back, content length 278, response, it just cuts off. So it doesn't read that entire file because the browser's reading the content length and then reading that number of bytes from my body, from the body of my response. Once it reads that number of bytes, it stops reading bytes. So since each one of these I counted only for 1 byte instead of 4, I'm missing a lot of information here because the browser just stopped reading because it's trusting my content length. If I don't do this, if I use the good version of this, for this version, I'm converting the string to bytes and coding using UTF, and then taking the length of that byte array as my content length. So I forgot what the content length was, but it will increase. We refresh this. We do get the entire page. And the content length, I forgot what it was, but it's 314 now. I'm sure that it's more than it was. Since we have the whole page rendering. So remember, the UTF-8, if you're using non-ASCII characters, you cannot get away with using the length of the string. Even if you are using only ASCII characters, don't use the length of the string. It's just asking for trouble down the road. If you have any of these non-ASCII characters, it's just not going to work. It's not going to render properly. You're not going to have the end of your file. Yes, sometimes you'll get away with it because it's worth showing. Because the browsers, again, are going to try so hard to please us. Say I only have a few of these. I'll still get my whole page, kind of. But this is only because when I'm losing these ending tags, the browser's going to reach the end of the file and it's going to be like, they probably meant to close these tags. Like, they probably meant this. So again, the browser's going to help us out. Fortunate or unfortunate, depending on your view. I think it's a little unfortunate because we can have bugs in certain browsers and not know it because other browsers are going to help us out a little bit too much. So we can get away with that sometimes, but it will bite you someday. You're going to get in big trouble if you use the length of the string as the content type. I think that's it. All right, any questions at this point? And character encodings, content length, mime types. And with mime types, HTML, CSS, JavaScript, these are the most important mime types to get right. The browsers will help us out quite a bit. Even if we have no sniff, it'll help us on like images and other content. But the CSS and the JavaScript, that's where the security vulnerabilities come from. So that's where the browsers are really going to respect our no sniff and not even try to look at it. Not even try to render it as style or JavaScript, because that can really break things. That can really open doors for the attacker. An image, not so much. If you have JavaScript and the browser tries to display it as an image, not a whole lot that can break there. I'm sure clever hackers can get something in there, but it's not as crucial. But your HTML, your CSS, and your JavaScript, which I don't have on this server, those need to have the right mime types, and you should definitely have no sniff on those types, or else you're opening the doors for attacks. Okay, no questions? Talk about cookies. So HTTP is stateless. We talked about this before. When you get a request for that HTML, you send that HTML, and you get another request right after that for the CSS, like we just did in the example. You don't really have any persistence or state, so you don't really know that that's the same user who just requested your HTML. There are some ways you can find out, but HTTP is not inherently stateful. You don't really have anything in the protocol itself that tells you that that's the same user. You can check IPs, you can, maybe it was the same TCP connection, things like that, but HTTP does not have any statefulness. So if we want to remember anything about a user, we're going to use cookies. We're going to give them a cookie. We're going to tell them, hey, here's a cookie. Can you store this in your browser on your machine? And then every time you send another request to me, please send me that cookie again so I can know something about you. So I can use these cookies to remember things about a particular user. Cookies work strictly through HTTP headers, so ASCII only in these cookies. We can't specify any encoding for the cookies. Cookies work on two headers, and these two headers really do everything that is cookies. Maybe that's a little bit of an overstatement. There's a little bit more. The client can set it with JavaScript, set cookies with JavaScript too. We'll talk about that. But these two headers are really most of what cookies are. So if I have a response, if your server sends a response to a user, you use the set cookie header. Use a set cookie header with your cookie information. It's going to tell that user to set that cookie. Its browser is going to remember that cookie, store it, and send it with each request. Whenever you get a subsequent request from the same user, they're going to use the cookie header. So when a user makes another request, after you sent them a set cookie response, they're going to send all the cookies that you gave it with set cookie in the cookie header of their subsequent requests. And this is what cookies are. You've probably heard about cookies most of your lives. This is really what it is. These two headers in HTML requests and responses. That's what cookies are. It's not a whole lot to talk about cookies, to be honest. There is, but the actual functional details of it, how it works logistically, not a whole lot. So set cookie, this header, we're going to give a cookie as a key value pair. So we're going to set a cookie with a set cookie header, and we can have multiple cookies in a single response. We're going to set a cookie using key value pairs with the equal sign. So I'm setting a cookie named ID with the value of this mess, and now the user will set that, their browser is going to set that cookie in their browser. When I get those cookies back, I'm going to get them in the header. Our servers are going to look for this header called cookie, and it's going to be key value pairs separated by semicolons, and that one header is going to contain every cookie that we set. So if we have 20 cookies that we sent the user that we told them to set, they're going to send all 20 of those in this one cookie header. So we have to parse through all our headers, find the cookie header, separate them by semicolons, and read all the cookies if we have multiple cookies on our site. The client can also set cookies. This is why I had to backtrack when I said these two headers is everything. The client can actually set cookies as well. We'll look at cookies in the browser console. We can change cookies that way, just manually. You can also change cookies through JavaScript. So you can use your JavaScript to either set cookies or read cookies using this variable document.cookie. So if you go into your console, you do document.cookie, that variable stores all of your cookies in the format that they're going to be sent in the response. So that key value pairs separated by equal signs, and then each key value pair separated by semicolons. You're gonna get all your cookies in that format. Not necessarily all, we'll talk about that as well. But attackers can read these. If they have their malicious JavaScript running on your site, they can potentially see those cookies. They can just have JavaScript that says, send the value of document.cookie to my API on my server running somewhere, which is connected to a database, which is going to store them all. And now they have your cookies. So there's some we need to be cautious of, something we do have protections for. But it is something we have to be aware of, that any JavaScript could potentially read these cookies.
Only JavaScript on the site that owns the cookie, right?
Yes. So in my example of a user sending JavaScript instead of an image and that being
Yeah.
rendered on everybody's site,
If they
attacks
could
like that could,
Yeah, they
could
could
get,
somehow embed it into your page.
yes. So you have to be vulnerable to a JavaScript attack first, and you have to not be securing your cookies.
But your rando internet store cannot access your bank.
Right. Yeah, you can't access cookies. So if you click CSE312.com, I can't see your cookies in any other tabs or any other windows or any other sites. I can't read those cookies. But if I can inject JavaScript onto one of those sites, potentially I can. It requires the developers to do two dumb things. Don't do either of these. One, don't be vulnerable to JavaScript injection attacks. We'll talk more about that when we, next week when we start talking about posts, once we start handling user-generated content. We really got to worry about what that content is. We can't trust any of it. We have to make sure that they're not sending something malicious. And also securing our cookies on a few slides from now. So this is something we have to be aware of, though. A careless developer could open themselves to these vulnerabilities and have their cookies hijacked. Oh, speaking of cookie hijacking. So, and one of the main uses for cookies is to store session information. So we want to remember in that example, hey, give me your HTML, hey, give me your CSS. A lot of times we want to know that is the same user. So we'll give them some session token to identify them. They'll send us that session token with every single request. We'll go to our database, look up that session token, get all the information, all the history of this user, and then do whatever we need to do with that information, whatever we'd like to do. So, and we also give these after authentication. So session tokens to remember the user, authentication to remember that they have authenticated. So if you type in your username and password, you're going to get an authentication token in a cookie, and then you send that authentication token back with every request. They look in the database, say, oh yeah, this person is authenticated with this username. At some point, since they have this cookie, I must have verified their username and password. So it's not going to ask for your username and password every single time. It's just going to look at that cookie. But if somebody takes that cookie, that authentication cookie, they can masquerade as you without even cracking your password, without knowing your password at all. They just take your cookies. In fact, they wouldn't even have to know your username. They just take those cookies, they go to that site, and it'll say, hey, welcome, username. How you doing? Here's all your information. So we have to make sure these cookies are secure, especially when we're using them for authentication. The authentication details, that's not till after spring break. But for now, just know the cookies can store authentication information and identify and verify our identity through those cookies. Needs to say these need to be protected. We have multiple directives, what we call directives in cookies, that give more information attached to a cookie. One of these two we should have with any cookie, either expires or max age. So these are additional information we can give with a cookie, and they're separated by semicolons. So for example, in the set cookie header, we give the cookie name, cookie value, and then semicolon separated directives. So expires in this format, expires, and then the expiration time in this exact format. It's a very specific format, has to be in that format, and then that's going to be the expiration date of the cookie, when the browser should delete that cookie and no longer be sending it in subsequent requests. We can also do max age if we want to say after a certain number of seconds, 1 hour in this case, this is when the cookie should expire. We can also set it like this as well. If we don't use either of these, then we have a session cookie, which is going to be deleted as soon as the user ends that session. They close their browser, close that tab. That cookie is done after that, which isn't super useful, especially if we want to have authentication tokens. So next time the user visits our page, we don't want them to relog in. The session cookies aren't really helpful. So expires or max age to specify the age. When should this cookie expire? Talking about the security holes, we should secure our cookies. How do we do that? Well, there's not a whole lot we can do, but the one thing we can do is super easy to do. When you send the cookie, give it the secure and HTTP only, depending on your application, send it these two directives to tell the browser either secure or both. Secure, only send this over secure channels, only send this over encrypted channels, which is, for our purposes, HTTPS. And HTTP only, don't let them access this cookie using JavaScript. Now those attack scripts don't really have a chance. This cookie is not exposed to JavaScript. When you do document.cookie, any HTTP only cookie doesn't even show up. So it's a super easy thing to do. You just add this to your cookies, and now the attack script can't really mess with those cookies. So easy to prevent a majority of simple attacks. No excuse really not to do it. But and then I end up adding that slide. I had some more commentary on it in a slide, but I want to talk about it. Secure and HTTP only. These are directives for the browser. There's no magic with these. It's just literal text that's part of the header, but it's an instructive or directive, as the name implies, for the browser on how to handle this cookie. So it's really up to the browser to respect these. If somebody's using an outdated browser that existed before secure and HTTP only existed, or just didn't feel like implementing it at that version, then these don't do anything. So if somebody's using an outdated browser, these directives might not help them at all. Or if they're using some, I don't know, maybe there's some crazy prototype browser out there, might not have all the security features implemented, they might ignore these directives. There's no real guarantee. There's one advantage of using a major browser. Use one of the major browsers. They're going to respect this secure and HTTP only for us. But it is up to the developers of the browser. There's nothing saying they have to. The documentation says, yeah, you definitely should respect these. The developer doesn't have to write that code. So one thing to be aware of, users using outdated browsers, this might not be enough to protect them. And finally, path. If you want to set a cookie only for specific paths, you can specify the path directive. In this example, path of posts. This cookie is only going to be sent by the browser for paths that begin with /post. So it's /post/56, so get the 56th post, if that's how your stuff's set up. That's going to send the cookie, but like /index.html, not going to send the cookie. Any questions on this? Yeah.
Some of these set cookie directives, if you're, let's say you have a pretty complex page, and there's different, can you send different ones in your browser, just kind of cast those, and say these cookies are sent for post only, then these other ones that just apply to all these pages, same thing?
You would, yeah, you would set, so you can use multiple set cookie headers in a single response. You would separate them through just writing a bunch of headers. Was that your question? Does that make sense? So for example, I can see my cookies. If you go into the browser, go to application, you can look at all of the cookies that you have set. And here on Twitch, I got all these cookies. A lot of them are just for sessions. I'm not logged in, so none of these are authentication cookies. But I can see all these, random looking strings, all strictly ASCII characters, of course, because they're headers. They were read from headers. But I can see all these random looking values, and these are just keys that they're going to use when I send a request with these cookies. They're going to take these keys, go to their database and say, give me the information for this key, and then do whatever they're doing with this stuff, usually tracking us for ads, unfortunately. As we can see with these other ones, I have a few Amazon cookies when I visit Twitch. Not altogether surprising, considering Amazon owns Twitch. So Amazon's watching us when we're on Twitch, so they can try to sell us stuff next time we go to Amazon. They're going to say, hey, looks like you like that video, like that streamer. Here's some stuff. And then some other, I don't even know what this one is, to be honest, krxd.net. It's a CDN, so it can't be too malicious, I wouldn't think. An image world. So we have these cookies, but let's Can't clear them all. So let's clear these cookies. We can just delete them. We have control over our cookies. You should never trust your cookies. You should always verify when you receive a cookie. But let's delete those and refresh this page. And in this first request that we make, we're going to see the set cookies. So it says, okay, you made a request. You didn't give me any cookies, so Twitch is going to generate some cookies for us, put them in their database, associate them with us. They don't know who I am because I'm not logged in, but they still want to track me. They're going to give me these cookies, store them in the database, and then say, set cookie, this one, this is your new ID. This is going to identify you as long as you're on Twitch. With some ridiculously high expiration date. This is going to last for 10 years. Some server session on, it went on the next line. With no expiration, question mark? And my country, it knows that I'm in the US. Looked at my IP, figured out my location, and said, you're in the US, so I'm going to mark you as a US user. Now, next time and we won't see anything down here in my request. But next time we have a request to twitch.com, this is twitchsvc.net. So this, I'm not going to have any cookies. Oh my goodness. Scroll for me. No cookies. Twitch CDN. Skip ahead here. Let's just refresh because I don't feel like digging through. So next time I send, first I don't get any, I did get one because I did get one set cookie. I got 2 set cookies, but not the one, but not these ones that I already have set. So the cookies that were already set, now when I have a subsequent request with Twitch, I'm sending all of those cookies over to Twitch and it's saying, hey, these are all the cookies you told me to set. Here they are. They mean something to you. They don't mean anything to me. So we're sending those each time we go back to this page. Any quick questions? It's same site that was up. I didn't cover all the directives in these slides. This is how strict it should be about giving this cookie to other sites, which I believe it shouldn't do it all, but that's saying how much it should respect that same site, that origin of that cookie. Yep. Better to what? We can. Oh, no, the order doesn't. Anyway, I'll see everyone Friday. Have a good day.